Welcome back to Fabulous Creations. I'm Ron, and in this video I'm going to show you how I set up and installed ventilation through my garage roof in order to ventilate smoke from my laser cutter. Now I planned this ventilation project alongside the rest of my garage finishing, so you'll actually see that the work takes place over the span of a few months as the insulation and ceiling coverings went up around it. But do know that many of the same principles can be used if you're installing your ductwork in an already finished area, or if you have easy access to your attic space to install the ductwork up there. I'll go over the supplies I used as we go, and I'll have a list linked down in the description for you when we're done. With that, let's jump on in. First off, let's discuss why I decided to vent out the roof of my garage rather than the sidewall. That certainly is a valid option, much like how a household clothes dryer usually vents straight out the wall behind the unit. The biggest reason I chose to go with the roof, however, is in case I want to reorganize my shop or move stuff around at some point. Putting a 6-inch hole in the side of my garage and then later moving my laser would result in me either having to 1. Try to repair the hole in my siding and drill a new hole somewhere else, or 2. Have ducting run from the new location to the old location. If that old location is intended to have a large piece of equipment in its place as well, obviously the ductwork could get in its way. By having my ductwork exhaust through the roof, I can simply run a new line up to the attic from the new location and attach it to the existing ductwork with a little foil tape and some straps and have it vent out the same location in the roof. I made a rough plan in my head of what pieces of ducting I would need and picked them up at my local Home Depot. Those pieces were a single 5-foot span of 6-inch ducting and 2 variable angle or elbow attachments. I measured roughly 5 feet from the wall up along the underside of the roof sheathing and along one of the trusses to find where to place my 6-inch hole. Once I found where my hole would go on the roof, I marked the center with a Sharpie through the 6-inch hole saw I bought for the job and then proceeded to tap a nail up through the sheathing and roof shingles. This way, when I got up to the roof, I would know exactly where to drill my hole. Once up on the roof, it was time for the real fun to begin. I've never really been afraid of heights, so any chance I get to go up on the roof is fun for me. Unfortunately, drilling the hole wasn't that fun. I'll get to that, but first I had to cut away some of the shingles in the location where my gooseneck vent would go. I measured the width of the hood portion, not counting the base, then divided that measurement in half. That was the distance I needed to cut on each side of my nail so that shingles could overlap the base once installed. After scoring straight down in these areas with my utility knife, I cut across perpendicularly to remove the pieces of shingle. Removing these pieces of shingle would allow me to slide the base in underneath the shingles above the hole. If that doesn't make sense now, don't worry, it will in a bit. Let's get to drilling that hole. Like I mentioned earlier, I purchased the 6-inch hole saw since I'd been installing 6-inch ducting, so I thought surely this would make it a breeze. What I guess I didn't anticipate was how much effort it takes to cut through the sand, gravel, and tar that together make up asphalt shingles. I went through 2 fully charged batteries in my cordless drill before I realized it wasn't going to happen with battery power alone. I don't own a corded drill, but thankfully my neighbor Carson came to the rescue and let me borrow his. Even with his plug-in drill, it took a decent amount of drilling to finish the hole. I discovered afterwards that the initial drilling through the shingles likely dulled and sanded down the teeth of the hole saw to the point that even once I got to the wood, it took a while. So, I'd recommend saving yourself the $40 that this size hole saw costs and just use a jigsaw to cut the hole. It maybe won't be a perfect circle, but it really doesn't need to be, as long as it's close. I finally made it through both the shingles and the roof sheathing, no worse for the wear. I had used a paint scraper to gently pry up the adjacent shingles so that the base of my vent could slide in underneath, but it wasn't able to go far enough in some areas, so I used a crowbar to help out. I did a test fit and found that since the duct portion of the vent was exactly 6 inches, it would have been difficult to get it in the hole as is. But that was okay, as I needed this end to be a female crimped end anyway. So I used a ductwork crimping tool all around the perimeter, bringing it down in size a little bit. This crimped edge will connect to an uncrimped piece on the inside of the garage. After it was crimped, I could do another test fit and found that it now fit in the hole just fine. Next up, sealant. I bought an outdoor rated caulk made for roofing, and after a bit of struggling to get it open, applied a heavy bead around 3 sides of the base of the vent, the top, left, and right, purposely excluding the bottom side. This is to permit any moisture or condensation that may get trapped underneath, such as moisture from the air in my garage, a way to run off down the roof, rather than get trapped underneath the vent. After this bead was applied, I carefully lifted up the adjacent shingles and slid it in place, taking care not to smear the caulking before it was in place. Once it was properly seated in its hole, I put gentle, even pressure all around the areas where the caulk was to more evenly distribute it. Then, it was time for a few roofing nails to make the installation a tad more secure. I lifted the flaps on the left and right side of the vent and applied a single roofing nail in each location straight through the metal base of the vent and into the roof sheathing. Now I'm sure you'll notice that I have an extra gap on the right side of the vent here where the shingles don't fully overlap the side despite my measuring on both sides of my nail earlier. When I did the scoring with my utility knife and removed those pieces, the second layer of shingles that I found underneath this side was the last few inches of a different shingle that had gotten a little damaged from my prying. Rather than trying to reattach it or glue it back on and create an area where moisture could get trapped, I just let that side be a little wider. Not a huge deal, as water can still run off effectively. After the vent was nailed in place, I applied a heavy bead of the same roofing caulk under the shingles that I had pried up for the installation to resecure them. I also applied a heavy bead of caulk behind the vent where it met the shingles, as I wasn't really able to lift them up in that area to do the same glue down treatment like I did with the sides. This way, water shouldn't be able to make its way up underneath those shingles, and instead should just go around the vent to either side. I smoothed the caulking out wearing an old gardening glove, as nitrile gloves were a tad hard to come by at the time. Back inside the garage, I could now connect my ductwork to my newly installed vent. The 5-foot length of ducting was a tad long when used with my angled connector, so I trimmed a bit off using sheet metal shears. Though I accidentally screwed up and trimmed a bit too much off on the opposite side of my cut, so you see my hack job attempting to repair it before actually attaching it to my elbow connector. That's why there's already foil tape where there wouldn't normally be. Thankfully, attaching the elbow connector requires that same foil tape, so my mistake was mostly covered up by my intentional tape. Also, I don't know how important this was, but I made sure to get the foil ducting tape that was rated for cold and hot temperatures, since this will be up in my unheated, unconditioned attic, and I don't want the adhesive failing on days where Mother Nature, Minnesota edition, decides we need negative 20 degrees Fahrenheit temperatures. Once the elbow was taped onto the main length of ducting, I could raise it up to meet the underside of my gooseneck vent. Unfortunately, there wasn't enough length protruding from the vent to securely seat it in my ductwork and do the normal tape work to secure the two pieces together, so instead I raised it up to be flush with the sheathing and then used self-tapping sheet metal screws to secure the two pieces together. After this, to fully seal it up so I didn't have trace amounts of smoke leaking into the attic from this admittedly imperfect joint, I used a product called Duct Seal that I had left over from installing an outlet on the outside of the garage. It's a non-hardening clay-like compound that you can form to the area you need sealed and press it right into place. And it sticks to most dry surfaces without issue, including the wood sheathing on my roof. I learned about it from the electrician who installed my sub-panel. It's what electricians use behind outdoor junction boxes to prevent bugs and moisture from getting in through the hole behind the junction box. On the other end of my ducting, I secured the portion that would enter the room below to the wall with some metal strapping. The project would then sit in this state for a few months as I finished up other aspects of the garage and finished deciding which laser I would be buying. The next step of garage infrastructural work that involved the ducting was attic insulation. I already did a video on how I insulated my garage, so you may have seen portions of this before, but I basically just needed to reduce the height of my insulation along the length of the 6-inch duct that would otherwise compress it. I tried to do this in a wedge shape as to only remove as much insulation as needed, after which I could just staple it up into place. For the final piece of insulation where the duct entered the room, I tried to be clever and used the hole saw from earlier to cut the circular shape needed from the insulation, and it actually worked better than I thought it would. I did need to tug and tear the paper a bit to go fully around the duct, but otherwise it worked just fine. After that, the project sat a bit longer as I completed the insulation and the rest of the attic, after which I had my buddy Kyle come over and help me install some of the ceiling plywood. I'll touch on it a bit more when I edit that video, but don't do it like we did. Rent a drywall lift. It's so much easier than holding it in place with your head. I carefully measured it probably 5 times and then cut a U-shaped slot out of the side of the plywood that would wrap around the duct. Then we carefully lifted it into place and secured the board in place. After putting yet another brief hold on the exhaust project as we finished up the ceiling work and waited for my new Thunder laser to arrive, the day finally came and I found myself the proud owner of my very own laser cutter. But I couldn't use it until it was connected to my exhaust system, so I quickly got to work to conclude the project. Now, the Thunder laser ships with an industrial-style exhaust fan, which works great, but these things are known to be quite loud. You definitely don't want to be sitting in the same room as one of these constantly without wearing hearing protection, and I'd prefer not to need hearing protection when just doing laser work. So I decided to go with another popular option in the laser community, which is an AC Infinity Cloudline Inline Exhaust Fan, which is a much quieter option for only around $150. The trade-off, for what it's worth, is that the reason they're so quiet is because they use pulse width modulation motors, which take 10 to 15 seconds to get up to full speed compared to the industrial style that gets up to full speed within the first second or two of turning it on. This means that if you have your laser control software turning on the exhaust fan right when the cutting begins, you may have some smoke accumulation in the laser prior to the inline fan getting up to speed to suck it out. You can overcome this in a few ways, such as having the exhaust fan have its own switch and simply starting it prior to sending your job. I've been letting the laser control the exhaust though, and I haven't noticed any issue with an overwhelming amount of smoke accumulating before it gets up to full speed. If I ever do, I'll probably just put it on a smart switch and turn it on before I send my job to the laser. To install my AC Infinity Fan, I first installed the motor housing bracket about 6 inches below my in-attic ducting using the provided screws. I then cut a short length of the flexible ducting that came with my Thunder laser to connect the exhaust fan output to the inlet of my attic ducting, which I secured with large hose clamps. It's worth noting that it was a little difficult for me to get the flexible ducting around my rigid ducting because of how close to the wall I had it. I should have had it sitting an inch or so away from the wall rather than right up on top of it, which would have made this step a lot easier. Just a tip for you. But I eventually got it fitted between my wall and the ducting. After that, I could install the motor and fan back into the now mounted mounting bracket. This involved strategically placing a channeled ring around the seams where the motor and bracket meet. A little tricky to explain, but not too difficult. Finally, I could attach a much longer length of flexible ducting to the inlet side of the exhaust fan and, drumroll please, connect it to the outlet of the laser cutter itself, again using metal hose clamps. You may be wondering why I use flexible ducting for this portion rather than rigid, and it's mostly for that exact reason, flexibility. I don't need to worry about it being perfectly positioned with the laser like I would with rigid, and if I need to pull the laser out to service the tube or such, it's much easier to do with flexible ducting. So, how does it work? Well, lucky for you, Minnesota got an extended full spring with a few 60-degree Fahrenheit days here in early March, so I was able to get up on the roof of the garage to show the whole system in action and see it in action myself for the first time too. Since it was well into winter when my laser arrived and I got to first use it, I've been basically just trusting my work this whole time, which wasn't too big of a stretch because it would have been pretty easy to see if smoke was building up in the room if it hadn't been exhausting properly. So, here it is. The motor comes on in the room below, and as the fan slowly gets up to speed, it opens the internal flap to let the smoke out. And let the smoke out it does. Now it's worth noting that I wanted the smoke to be especially visible for the camera, so I set up a laser job with some overkill raster settings to really produce a decent amount of smoke for the system to exhaust. The smoke produced by normal job settings wasn't super visible once it was mixed with the fresh air and wind outside the garage, and I really wanted it to show up on camera. So, there you have it. Now I hope you found this video useful if you're planning your own laser exhaust system. Proper ventilation isn't only key for getting smoke out of your laser, but by extension, increasing the longevity of your laser internals. As a reminder, if you are planning a project like this yourself, I have a list of the tools and supplies I use down in the description. If this video was helpful to you, I sure would appreciate a thumbs up so other laser enthusiasts might find it too. And one last thing, I've got a ton of projects queued up with my new laser, so be sure to subscribe if you're interested in more laser content from me. Until next time, cheers.